All right, so we've talked about how we classify rocks based on their formation, but also on their textures. Now we're going to talk about igneous rock textures. Right, so cooling rates of a melt affects igneous rock textures. Right, so if the melt cools very, very slowly, the rock is going to look one way, or if the melt cools very, very quickly, it's going to look another way. Okay. So intrusive igneous rocks, those are the ones that cool slowly underground. I think of the earth like a thermos. So if the magma is within earth, the earth is acting like a thermos around it, keeping it hotter for longer. So it's going to cool very, very slowly. And when rocks cool very, very slowly, the minerals have plenty of time to crystallize, and those crystals have plenty of time to grow really, really large. So when rocks are intrusive, meaning they cool within the earth, they have a texture with very large crystals. They're coarse grained. So we call that texture phaneritic. So when I look at this rock, which is granite, I can see the different crystals. I can see the pink crystals. I can see the black crystals. I can see the white crystals. I can see all of the individual crystals. So they're big enough for my eye to see. I know that this rock must have formed underground. It's an intrusive igneous rock with a phaneritic texture. On the other hand, once magma reaches the surface and that lava spews out onto the surface, it comes into contact with relatively cold atmosphere and it's going to cool very, very quickly, right? It's no longer within the insulated earth. It reaches the atmosphere and it cools quickly, so quickly that the crystals don't have very long to form and not much time to grow. So instead of really large crystals, instead the crystals stay really small and you get a lot of tiny crystals. And those tiny crystals are so small that you can't actually see them with your eye. So when I look at this rock, which is basalt, the crystals are so small, I don't see the individual crystals. It just looks like a plain black rock, right? I can't pick out the different minerals. It's just one black rock. And we call that texture, when there's really fine grained crystals, really small crystals, we call that texture aphanetic. So intrusive rocks have large crystals, phaneritic texture. Extrusive rocks have really small crystals, aphanitic texture. The final texture we're going to talk about is glassy, like obsidian here. So obsidian is a rock that cools so quickly that crystals don't get a chance to form at all. It's not that the crystals are too small to see, it's that there is no crystals, right? They didn't have a chance to form at all. And we call this a glassy texture because it looks like glass. All right, so we've talked about how we can classify rocks based on their composition, from felsic with a lot of silica to mafic with not a lot of silica, and how we can classify igneous rocks based on their texture. If they're extrusive, we can see those, we can't see those crystals, right? So they have an aphanitic texture. Or if they're intrusive, meaning they cooled within earth, they cooled slowly, we can see those large crystals, so they have a phaneritic texture. And remember that igneous rocks can form wherever there is molten rock. And molten rock often occurs at plate boundaries, both divergent plate boundaries where magma is upwelling to the surface at that divergent plate boundary, or convergent plate boundaries because flux melting causes a lot of volcanoes to be created at convergent plate boundaries. They also happen at hotspots. Okay, remember, hotspots are those mantle plumes that well up just in the middle of a plate not really associated with a boundary. All right, that's all for now on igneous rocks. Next up, metamorphic rocks.